This conference will now be recorded.
I hope we can hear me right. Can someone confirm?
We can hear you now.
Yeah, thank you. So let's talk about different types of tables in Hive today. I think I haven't covered this, right? So did I cover this? Did anyone remember? I think I haven't covered this. So I'll talk about this now.
No,
We are
Manish,
backing
we missed that actually.
Yeah, I'll talk about it now. Yeah.
We directly jumped into partitions.
Yeah, I got it. Yeah. I thought I covered this, but no problem. We'll cover this today. So there are actually two types of tables in Hive. Managed table or internal table, both are same. And the second type of table is external table. So first, let's go to the hands-on. I'll directly go to the hands-on, then I'll come back to this. So let me go to the Cloudera Quick Start VM. So just right click, say open in terminal. Then you can launch Hive. Terminal, set title, give it as Hive, click on OK. Click on view on zoom in. And let's see the list of all the databases, show databases. I don't have anything, just the default database. Let me create a new database. Create database, if not exists. As we want to talk about tables in Hive, let me give the name as Hive underscore tables. So I would like to switch to this database called as Hive underscore tables now. Use space Hive underscore tables. Then say show tables. There is nothing right now. So we will create a table. Now I'm going to open other terminal. How to open other terminal? Just click on this. You should be able to open other terminal. Let me do that. So click on terminal, set title, give it as, let's say, MySQL, because what is MySQL? It's nothing but the Metastore DB that we are using, right, in Hive. So I'm going to connect to MySQL Metastore DB here in this terminal. So MySQL space hyphen view root, username is root. -p password. Password is Cloudera. And then I'm going to open one more terminal for running any of the HDFS or Linux commands. Then you can click on view and zoom in twice. And let me go to my downloads folder. So I'm in my downloads now. I have a file called as orders. So this is the file that I'm going to use. Headspace orders. Right. So these are my top 10 records. So let me talk a little bit about this data. So this data is actually nothing but the e-commerce data. If you go to Amazon and place an order, every order will have an order ID, right? So the first column is talking about the order ID. And then the second column is nothing but the order date, basically the date on which the order has been placed. And third column is order customer ID. So ideally speaking, in the real world, it would be your email ID or your mobile number. But to keep it simple, we have a number that we are being used as the order customer ID. That's an integer value. Fourth column is order status. If you place an order, the order goes through multiple states or multiple phases. So suppose if you go for cash on delivery, then it could be pending payment. Suppose if you already made the payment, then it might be in the processing state. If order gets delivered, it could be either closed or complete status. So a given order might go through any of these order statuses. So we got some idea about this data. Now, by using this data, I want to create a managed table in Hive. So let me just directly take one of this record. I'll copy this. Let me go to my desktop. Right click, say create document, empty file. We'll talk about tables in Hive, Hive tables. And I'm going to paste that record. So we are aware of these columns, but I'll just rename them again. This is order ID column. The next one is order date column. Third one is order customer ID column. And then the fourth one is order status column. So these are the columns that we have got. Based on this, let us create a managed table. Create table orders. Then you have to define all the column names. First column is order ID, which is of integer type. Second column is order date, which can be of timestamp type also. And third column is order customer ID, which is an integer. And fourth column is order status, which could be of string type. And then row format, delimited, fields terminated by comma. So why do we need to give this line, last line? Because if you look at the data that we have got, all the columns or all the fields are separated by comma, right? So that's why we have to give that last line saying row format delimited fields terminated by comma. So this should be good enough to create a managed table. Let's copy this. Go to the Hive terminal, right click and paste it. Say show tables now. I should have this table created. I can see the table called as orders created now. So let us describe this table. So to describe this, you can say describe space table name. Then table keyword is not required. Just describe space table. That should be enough. You can see that we have got 4 columns in this data. Sorry, in this table. And you can also see the respective data types. So you don't need to give a full name called as describe. You can even give a shortcut called as GESC also, that works. That's going to give you the same output. Also, by looking at this output, we are not clear or we want to get more information, right? So in that case, what you could do is you could use extended, describe, extended, and then the table name. So you can see that we're getting different columns. Also, we can see detailed table information, but unfortunately, we cannot read this. This is not readable. So let us get the output in the readable fashion. So for that sake, I'm going to replace extended with formatted. Now this is a lot more better and we can read it easily. So we can see the different columns here on the respective data types. Along with that, we can also see this table belongs to Hive_tables database. It was created by the Cloudera user. You can also see the time at which it has been created. And more importantly, this is a managed table. So one of the entire question is, what's the default table that gets created in Hive? The answer is managed table. And to see what type of table is that, you have to check this table type. It's showing as managed table. And also you can see the field delimiter is showing as comma, right? Because all the fields or columns are separated by comma. So let's say you join the project, right? And you're not sure how the table has been created, right? So in that case, what you could do is you could run a command called as show create table, right? So show create table is the command that will tell you how a given table has been created. So show create table and then the table name. And you can see that you're going to get this interesting thing where you'll get an idea about how a given table has been created. So this comes handy sometimes when you join any project, right? So let me go back to the describe formatted once again. So here you can see that there is a tag called as location. Let's copy this. Right click, copy this. Go to the HDFS terminal. So here you can just set EFS space -ls. Right click and paste that path. Okay, I think I have to give HDFS as well, right? This should work now. Okay, there is nothing because within a database called as Hive_tables, we have created a table called as, within this database called as Hive_tables, we have created a table called as orders. Hence, for a given table also you will have a dedicated directory, right? And it doesn't have any data. You can see from the above output, we don't see anything because we have just created the table, not yet loaded the data. Let's say how to load the data. So my data is available in downloads folder. Let me go to downloads folder. So it's in downloads folder. The file name is orders. So I have to give this full path to load the data into this. So let me just use the load command to do it. Load data, local in path. So give the full path of your file. So home, Cloudera, downloads, orders. Then you can mention the table name into table. Table name is orders. Let's copy this and go to the Hive terminal. Right click and paste it. So this should be loading the data for me. You can see number of files is showing as 1 here. What is the meaning of this? Now the data must be populated in your orders directory. So have a look here, we can see the data, right? Now let's query this table. Select star from orders, limit 10. So limit 10 will give you top 10 records. Now you can see that we're able to see the data. right? So managed table is also called as internal table. And why is it called as managed table? Because it's managed completely by Hive. And also remember, by default, whenever you create tables in Hive, it's nothing but the managed table or the internal table. This point is important. For every table that you create in Hive, there will be corresponding directory getting created in HDFS. Also, an entry for the table is created in the metastore DB. Let's see that. So with respect to data point of view, we have seen that actual data is stored in HDFS. Now the metadata for this table is stored in the metastore DB. So let us have a look at that. So let's go to the metastore DB. This is how you can connect to the metastore DB. I can say show databases, and I have this database called as metastore. So I'm going to connect to this metastore DB. Use space metastore, and then say show tables. So you can see there is a table called as TBLS. Let's query this table. Select star from TBLS, and let me just zoom out a little bit so that you can see it clearly. Let me rerun it again. Now there are plenty of columns, but focus on only two things. Table name is showing as orders, and table type is showing as managed table. So these are the couple of things that you should focus on, right? So whenever you create a managed table in Hive, you will see the corresponding metadata entry getting created here. So this is the metadata that we have to look for. Right. So whenever you create a table in Hive, it will create a corresponding directory in HDFS. Also, an entry will be made for that table in the metastore DB. So this you have seen. What will happen if you drop the table? Let me drop the table. So before dropping the table, I'm going to say show tables. So I can see the table called as orders, and I can also see the corresponding data available here, and I can also see the metastore DB for this table. Let me drop the table. Drop table, and then the table name. Table name is orders. If you drop your table, drop table. Now if you just say show tables, you don't have any table with the name called as orders, right? Suppose let's say that I will say select start from orders. So actually speaking, this is the correct query as per the syntax, but let me make some syntax errors here. Instead of from FROM, I'll give it as FRM, which is syntactically wrong. Hit enter. Now you can see pass exception. Why? Because what is the reason behind this? When which component is throwing this? I'll go back to the architecture of Hive. So we are running the Hive queries from Hive CLI. So the first point of contact is driver. So driver will pass on that query to the compiler. Compiler will check whether the given query is correct as per the syntax or not. Now, as the given query is not correct as per the syntax, it's going to immediately fail the query by saying parse exception. So to answer my question, parse exception is being thrown by the compiler because there is a syntax problem here. Let us fix the syntax problem. I'll give it as FROM from. This is correct as per the syntax now. Hit enter. Now I see semantic exception and it's saying as table not found. So let's go and check the metadata entry here. This was before dropping the table. Now I have dropped the table. Metadata entry is gone. So whenever you drop a table, your metadata entry will be removed. And this query is actually again going through the same process, right? We are running the query from Hive CLI. It's going to the driver. Driver is passing on to the compiler. Now the compiler is checking, okay, the given query is correct as per the syntax. So this will pass the compilation check. Then it will go to the metastore DB. Now metastore DB is going to check whether the metadata is available or not. But as we have dropped the table, metadata entry is not there. Hence, it's failing the query by saying semantic exception and the table is not found. Semantic exception is being thrown by the metastore DB because the given table is not found in the metastore DB. Because have a look here clearly, we don't have anything because we have dropped the table, right? So metadata point of view, we are very clear. When you drop your table, your metadata entry is gone. What about actual data? My actual data was stored in HDFS here. Will it still be there? Let's find out. It's not there because when you drop your table, it will completely destroy everything, including the actual data that is stored in HDFS. Have a look here. Now the database directory is completely empty because we don't have any tables also. You can even see the show tables output, right? There is nothing. After dropping the table called as orders, we don't have the table orders available. So when you drop a managed table in Hive, it will drop both the actual data that is stored in HDFS and the metadata that is stored in the metastore table. This is very important to remember. Now the question is when to use managed table. You should use managed table when you feel that the data that is being used is temporary, right? So yesterday I've shown with respect to one example, right? In partitioning, we were using a staging table as the managed table. That's where, that's what I meant whenever I say data is temporary, because we were truncating that table so that next day we'll get new data into that table. And coming to the first point, so whenever you want the complete control to be under the Hive, right? So basically complete life cycle should be under the control of Hive. That is right from the creation of the table, loading the data into the table, and querying the table, dropping the table, everything is under the control of Hive, right? So in those situations, you should think about using managed table. Let's talk about external table, how to create an external table. So it's very simple to create an external table. I just have to add a keyword called as external. So I'm going to add a keyword called as external. That's it. Now just to identify it easily, I will give the name to this table as orders_ext. This name can be anything. Again, to recognize easily, I'm giving it as ext, which stands for external. Let's create this external table. Show tables. I can see the table called as orders_ext. Describe this table. So again, this table has got these columns, and you can see that this table belongs to Hive_tables database. It was created by the Cloudera user. You can also see the time at which the table has been created. And moreover, look at the table type. So table type is showing as external table. Under the table parameters, you can also see external is set to true. You can also see the field delimiters is showing as comma. Now let's go ahead and check the contents in your HDFS location. So we were already querying it here, right? Now if I query this database directory path, you should have a new directory available for your external table. You can see orders_ext, right? Let's go check orders_ext directory. Do we have anything there? We don't have anything there. So this table has been created but not yet loaded the data. Let's load the data into this table. Again, the same command, no changes. We can just use the same load command to load the data into the external table also. Sorry, the table name is wrong. I have to rename the table. Should be ext. See here, number of files is showing us 1. What is the meaning of this? Now if I query this portion, if I query this part, so you should be able to see the data available within this. I can see the data here, right? Now I should be able to query the table. So let's go ahead and query this table. Select star from orders_ext. So what will happen if I don't give limit? If I don't give limit, this will get me the entire data, right? So it contains 60,083 records, and it's getting me the end of everything. It's getting me everything. But I wanted to see top 10 records, hence I can just limit 10. This will get me only top 10 records. Right? So how to create an external table? You just have to use a keyword called as external, then you're good to create an external table. Again, whenever you create an external table in Hive, there will be corresponding directory getting created in HDFS. So this we've already seen. Now let us see the entry that is being made in the Metastore DB. So let's go to the Metastore DB and check the same. So this was the table before creating the external table. Now we have created the external table. You can see that the table name is showing as orders_ext, and table type is showing as external table. So this is the metadata entry that gets created whenever you create an external table in Hive. Right? So again, let's say that I wanted to drop this external table, right? So let's see how to drop this external table. Show tables, and I can see the table called as orders_ext. Let's say drop space, table space, table name. Table name is orders_ext. So the table has been dropped. Now let's say show tables. I don't have the table called as orders_ext. Right? So let me try to query this table again. So select star from orders_ext. Again, I'm going to make some syntax errors. So let's say this time I'll make a type of mistake on select. So ideally speaking, the select spelling is SELECT, but I'll remove one of the E here. Again, you can see parse exception. Parse exception on select. Again, which component is throwing this? Compiler, right? It goes through the same flow for every query that you run. So you are running the query from Hive CLI. It goes to the driver first. Driver is passing it on to the compiler. Compiler is going to check whether the given query is correct as per the syntax or not. So the given query is not correct as per the syntax because it has got some syntax problem, hence it is failing. Failing with what? Failing with parse exception, right? So let us fix that syntax problem. So it should be SELECT, select now. Now let's query this table. Now this query is correct as per the syntax. So it will pass the compilation check, it will go to the Metastore DB, right? And it is saying semantic exception, table not found, table name is orders_ext. So do you have the metadata information now? Let's check. I don't have the metadata information, right? Now as the metadata is not there, again, whenever I run the query, it will again take the same flow. It will start from Hive CLI and it will go to the driver. Then the compiler will check whether the given query is as per the syntax or not. Yes, the given query is correct as per the syntax. So then it's going to pass on that query to the Metastore DB. So the Metastore DB is going to check whether the given table is available in the Metastore DB or not. As it is not available, it will fail by saying semantic exception, table not found. So which component is throwing this semantic exception? It's nothing but the Metastore DB because the table is not found. Okay, now it's very clear that whenever you drop a external table, the metadata entry is deleted. What about the actual data? The actual data was stored in HDFS here. Will it still be there? Let's find out. Yes, it is still there, right? So the point which I want to make here is whenever you drop an external table in Hive, it will drop only the metadata that is available in MetaStore. The actual data in HDFS remains untouched. Very, very important point. One of the common interview questions is what is the difference between managed table and external table? We should talk with respect to dropping of the table. When you drop a managed table, both your actual data in HDFS and the metadata in the MetaStore DB is gone. But when you drop an external table in Hive, only the metadata in the MetaStore DB is gone. Your actual data in the HDFS still remains untouched. Right? Now, the question is when to use managed table. So you should use, when to use external table. You should use external table whenever you feel like that the data that is being used is permanent, right? In fact, you can create external tables, external partition tables also. You can give it a try. And also whenever you feel that the data is being used outside of Hive. So for example, there are some of the data files that are read and processed by an existing program. So we haven't spoken about Spark yet. So there is one important component in the big data world called as Spark. Whenever we talk about Spark, so we can actually use this data that is there in Hive external tables to create something called as data frames in Spark. So whenever we are working on such use cases, we should be using the external tables in Hive. Because if you use managed table and if you accidentally drop the table, the actual data also gets removed. So that's why whenever you work on some such integrations such as with Hive and Spark, that's where we should think about using external tables in Hive. Right, I hope it is clear. So there is one question in the chat which I got is, can we use any other field delimiter also like semicolon? Yes, we can do it, but you have to have the same data also available. So right now, if I look at the data, so I'm in my downloads folder now. Because the field delimiter or the separator is nothing but comma, I'm using the same in my query. But if you have a different delimiter, right, such as let's say hash symbol, pound symbol, or semicolon, or whatever it is, no problems with that. But the same must be used in your table creation query also. Otherwise, it will fail. Right? I hope it is clear. But also one more thing. So for running the HDFS commands, you don't need a separate terminal, right? So you can actually run your HDFS commands from Hive shell also. Let me copy this query or copy this command, and I'll go to the Hive terminal, right click and paste it. This will fail because I have to remove the HDFS keyword. This works. So we can run HDFS commands on Hive shell also by using this way. We'll get the same output. Right. So now let's talk about show tables. We don't have any tables right now, and show databases. So we have one database with the name called as Hive_tables. So let us see the corresponding HDFS location for this database directory. So we have learned that all the database directories will be available under this path, user Hive warehouse, right? Now you can see that we have a dedicated directory for the same. So the database directory is Hive_tables.db. Now let us drop this table called as Hive_tables, and you will see that the corresponding directory also gets deleted. Drop space database space, database name is Hive_tables. right? So remember that this database doesn't have any tables. Hence, I'm directly going ahead and then removing this database. Database has been dropped. Now let's say show databases. I don't have any databases apart from default database. So let's go and check the HDFS location under user Hive warehouse. There is nothing, right? Whenever you drop a database, the corresponding directory in HDFS also gets deleted, right? I hope it is clear. But what if you have a database with some tables, right? And what is the best way to delete it? I will talk about this. I will talk about that in the next session, right? So today we have seen the differences between managed table and external table, right? So in next session, I want to talk about some more operations that we can perform on Hive tables, right? So do we follow dimensional modeling in Hive? I think yeah. So again, we don't need to worry much about dimensional modeling, all those concepts, because as a database developer, we might be doing that, but as a big data engineer, so that may not be so much important, right? So one thing which I wanted to ask is, I hope everyone have set up the Cloudera Quick VM, right? Anybody need any help with respect to that? That's why I have ended the session little short today. I wanted to dedicate last 5-10 minutes of time to fix any of the Cloudera Quick VM issues. Anybody need any help with respect to that? Right? I think some of you have some issues with respect to Cloudera Quick VM setup. Let me know if you need any help. So that's why I have ended the session little short today. So one question which I got in the chat is, so do we have the primary key concept in Hive? We don't have primary concept in Hive. So now we don't have any primary key concept in Hive. Okay. So again, I'll come back to my original point. So anybody need any help with respect to setting up the Cloudera Quick VM, please let me know. Right after today's session, I will feel that everybody is done with the Cloudera Quick VM setup. Kiran, are you there? I think you need some help with respect to Cloudera Quick VM setup, right? Is it fixed?
No,
Is it fixed?
no, I reinstalled just now, but it's not yet.
Your voice is not clear.
Not yet, Vamsi.